Hey Tyler, so if you remember the first time I sent you a video, it was the first iteration of my parser. Well, this is the second iteration of my parser, including but not limited to variable names, different types. Now we have ints, longs, strings, floats, doubles, and technically support for any other type you'd want, but in the source it will just be determined to be a string. And it also has support for better strings now. It won't automatically take the white space out of strings now when they're wrapped up like this. And that's about it. The only thing that isn't supported now is arrays, but I don't really think I'm going to need them just now. The actual engine now is pretty much these lines right here. That's it. This is it. That parses all this information. So the first thing that parses the actual name of the variable are these two if statements here. The first one finds the index of the, what is it called, the ampersand. Now because C structs start at 0, the position of this ampersand is actually the position of the last character in the string. It's weird, but I don't care at this point. So what it does is it says the end of the variable is equal to the index, and then it duplicates, which in C lang is it effectively allocates, then copies the string that this points to, and what it does is it gets the address of the starting variable, or the variable we start at, or the position of the first variable, and it gets the address of this, and this is where we're going to start duping from, and then the length is just the end of the variable minus the beginning. Since variable start is initialized to 0, the first variable name we don't have to do any calculations for because we know that it's 0. But this next if statement, it says that if it comes across a semicolon, it knows that the next character it comes across will be the first character of the name or the first character of the variable, so it just sets the start of the variable to the index plus 1. Now the way we find the type and then the data is all done in one if statement, and I'm rather proud of it. It took a lot of iteration to figure out how to do this, but first, let's say we're looking for the type. It'll say the start of the type is the index plus 1. We have to remember it's weird, so we add 1. Once again, why this works and this works is kind of beyond me. I don't care at this point. So what we do next, the way we find the end of the type, is for the type, we say the end is equal to the start, and then we iterate over the end until it hits an equals mark, because that's what separates the type from the value, and we just add on to the end, and then we say the variable type, we strdup the type start, the address of type start, and then the length will be the end minus the start. And the way we find the data follows literally the exact same pattern, but it's data. And the way we see, are we ready to use this data, is if all of them are not equal to null, meaning the name has been found because it's been malloc, the type has been found because it's been malloc, and the data has been found because it's been malloc, we will print it, then we will free it, then we'll set them all back to null, so this block of code isn't triggered again until all three of these guys are found. And to do a little demo, we build it with make. Ignore this, I haven't gotten it fully working with data types. And then we can make run it, and here we see the window X, it's of type int, and it's 800. I'm pretty proud of this, but it's not finished yet because I don't know if I'll try and implement arrays. I don't think I will. I don't think I need them yet. But once I'm finished, this will be this is what the names will be put into, the data will be put it into, and I guess I don't need the mask anymore. Actually, I do. Int LSF type pointer called types, and yeah, this will just be used to tell the other parts of the function, like create a variable, get a variable, destroy a variable, what the type is. And the way it works is, if we have a name, let's call it window X, and it takes up the 0th position in the char star star array, and there's another piece of data, maybe it's 800, that's the 0th position in the void pointer array, and then the type is of type int, or LSF int, in the 0th position of the LSF type. Then when we go to get a variable, it will know that in the 0th position there is a variable named window X. It is of type int, and it has the data 800 in it. Or it won't know that it has the data 800 with it, and the only reason we care about types is so the user can tell the library that, hey, I want to use this type. And the library can say, oh yeah, this is what the type is, or it could say, oh no, it's not this type, but I'll still return it. And the other thing this comes with is a brand new, where is this error coming from? Let's use enum to, oh wait a minute. Enum. Alright, anyways, it uses a brand new project format, I guess, but it's a new way I figure out of storing not types, but libraries and utilities, and this is how I'm going to organize my projects from now on. I'll have a folder, and whatever the folder is, it doesn't matter, but it'll have an object folder inside of it and a library folder inside of it. And what the make file will do, let's go over to utils. It will go to the folder, it will compile everything down to an object code with its flags, and then it'll move the object code, it'll move the object code, which will be in the root directory, into the objects folder, and then it will effectively create a static library from those objects file and place it within the library tag, and it'll be given the name. It's because this is the folder utils, it'll be called libutils.a, and then when linking the main file, we will first compile it down to an object file, that's why main.o is in the root directory, and then we will compile the object file into the binary file by linking in both the O file. We'll link in the appropriate library positions, so in this case it's LibLSF, which is the parser I've shown you, and utils, which is what the parser uses for things like stripping its strings and loading a file to a string, and it will compile all of those statically into the binary file. And if you're wondering why it's called LSF, it's Lucas's serialization format. I guess if we're talking serialization, it might be in binary, and I might add in support for that, but as for right now, it's literally just going to be a text-based solution. But this is the format I've landed on. It reminds me of Rust. I like the way Rust looks, even though I don't like the way Rust works. But yeah, I'm really liking this. And of course, I've made it so there are no memory leaks. All heap blocks were freed, no leaks possible, because that really bugs me. But yeah, this is my project. It's halfway finished, I'd say.